It says explain why the diagram cannot give us a point that is equidistant to the sites C, F, I, and L. C, F, I, and L. We see that C and F and B have a little meeting point. We see that B, F, and L have a little meeting point, and then I is kind of isolated over here. And the reason why it's isolated over here is because B is in between I and B. So no matter what, if I am anywhere in here, B will definitely be closer than I will. And if I'm anywhere up here, B will be closer to this region than C, F, or L. So B kind of like interrupts that relationship, that spatial relationship, by being in between all of those things. So we can say something along the lines of like, since B is in between I and the rest of the sites, I cannot be included. I would, if I wanted to be super mathematical, I would say it couldn't be concluded in the point of concurrencies, the point where all of those lines intersect. But I'll say that I cannot be included in the trifecta or whatever. Okay. It says the point AA is equidistant to sites J and N. Find the value of A. So this one was a tricky one when I first read it. And J and N are right here. And we know that the perpendicular bisector between J and N is this guy right here. A point that is equidistant is the thing that I first zoned in on that problem. And it said, find a point that is equidistant. And my thought was, the midpoint. But then I was like, well, but any point on the perpendicular bisector is equidistant from J and N, right? The perpendicular bisector is the set of all of the points that are equidistant from J and N. So infinite amount of points along here are equidistant from J and N. So then I had to go back and I had to double check and reread and say, well, that's a lot of points. So what specifically about this problem says there's only one answer to this problem? And then I had to double check and say, they used the same variable, A and A, which means it has to be the same value. If you ever use the same variable in the same equation or in the same process, you are assigning it to be the same number. That's why we can do things like substitution, is because you say, well, x equals this and x equals this other thing. Well, x must equal x because it's the same thing, so we can substitute in for it. So when you use the same variable in the same problem, it's the same thing. So because it's A, it's a point that is on the perpendicular bisector where the x value and the y value are both the same. So looking at the perpendicular bisector, I try to look at the restrictions around the perpendicular bisector. I've got values that go up to, I think, 55 and then up to 42, it looks like, on the x values, 55 on the y values. And then the smallest y value I can do is 40, and the smallest x value I can do is 12. So I know that was a little bit hard to keep track of, but on the perpendicular bisector, my like domain, I guess, for the perpendicular bisector is between, I think that's 12. No, that's 10. And 42. And then my range for it, for the perpendicular bisector, going to the end of that perpendicular bisector, is 39 and 55. So trying to think about that in regards to it has to be the same number, we're thinking of numbers that overlap, right? I can't be 10 on my range because my equation doesn't go, my graph doesn't go all the way down to 10. So I know that like a value of 10 in my x coordinate is not going to work for my y coordinate because they need to be the same number, but my range doesn't go down to 10. So I need to be somewhere between 39 and 42, if that makes sense. That 39 would exist here and 42 would exist down here, but 38 would not exist within the range, so I can't go lower than 39. And 43 would not exist in the domain, so I can't go above 42. So I'm trying to think of a number between 39 and 42 that is on the perpendicular bisector and has the same x and y value for the coordinate. And so I'm trying to find those values. And 39 for my x value is here, but a y value of what looks like 41. 40 is 40 as well. So if I go to up just 1 to 40, here, well, that also has a y value of 40. And so the answer here is 40, 40. So there was a couple things in that problem solving process that I had to go through. I had to first establish what I knew about things being equidistant, what I knew about perpendicular bisectors. I then had to know that this was a hint that they had to be the same value. And then I had to think, okay, what are my restrictions on that line and how can I be the same value on that line, keeping in mind I can't have a 10 in my y value because it doesn't go all the way down there. Okay. Find the equation of the edge between sides E and K in the form y equals mx plus b. So as we learned in our perpendicular bisector notes, in order to write the equation of a line, we need a point and a slope. And the edges are all perpendicular bisectors. So specifically, the point that we need is the midpoint, and the slope that we need is the perpendicular slope to those 2 points. So we need to grab all of that information and then put it into our y minus y1 equals m times x minus x1, and then we'll have the equation of our line. Go ahead and find the midpoint for me. The midpoint is just the average between our values. That would be 8 plus 12 divided by 2, 28 plus 18 divided by 2. 8 plus 12 is 20, divided by 2 is 10. 28 plus 18 is 46, divided by 2 is 23. And that is our midpoint. Go ahead and find our perpendicular slope. The slope between those 2 points is negative 5/2. So the perpendicular slope would be the negative, so making that now positive, reciprocal. So that's going to be 2 over 5. So we now have the information that we need in order to put this together and find the equation of our line. So that'll be y minus 23 equals m times x minus 10. No, that is right. Sorry, hold on. My notes are incorrect. That's 20 divided by 5, which is 4. And now I'm going to double check because I'm a little bit unsure. So what I'm going to do, because I'm a little bit nervous, because my answer key I think is wrong, but I don't want to take the time right now to double check. I'm going to go up here and see where is E and K. E and K is right here. This would be the perpendicular bisector. It should have a y-intercept of 19, which if I extend that, looks to be accurate. Y-intercept of 19, and then a slope of 2 over 5. Hard to tell, but I think that is correct. Yeah, that seems to be correct because it's going up by a little bit and over by a little bit more. If I go like really into there, I can maybe find some points that would give me a for sure value, but that looks to be correct, and my answer key is wrong. Okay. So we also can create Voronoi diagrams, and typically your Voronoi diagrams for this level of this class will be like 4-ish points, maybe 5, but probably not. So creating Voronoi diagrams means we need to create a bunch of perpendicular bisectors. My recommendation is first starting with your triangle to be able to play off of what we talked about earlier of every triangle will have a point of intersection between all of the 3 perpendicular bisectors. It's guaranteed. So always start with a triangle, and then if there's more than 3 points, then you add the 4th one afterwards. So we need the perpendicular bisectors of 3 points. I'm going to start with ABC first and ignore D. Everybody should get a ruler out as well. It'll be helpful. This one is a pretty nice one because we don't actually have to calculate the perpendicular bisector for a couple of these. Since A and C are horizontal to each other, we know that the perpendicular bisector is just going to be vertical. And so I'm going to draw in a vertical line that's halfway between A and C. If A is at 2, C is at 6, halfway between is 4. I'm going to draw lightly because I'm going to have to be erasing stuff later. So right now, I'm just going to draw very lightly a vertical line at x equals 4. It's halfway between A and C, and it's perpendicular because AC is horizontal, and that line is now vertical. BC is also an easy one to find the perpendicular bisector for because it's vertical. So the perpendicular bisector will be horizontal. Finding the value that's between 6 and 0, halfway between, is 3. So if I draw a horizontal line at y equals 3, again, very lightly because I'm going to be erasing stuff later, I've now got the perpendicular bisector between B and C. And kind of comparing to our previous side of our notes, realize that like you can see if you just kind of visualize, okay, BC, perpendicular bisector, awesome. AC, perpendicular bisector, awesome. AB does not have a perpendicular bisector yet. We need to calculate what that is and then draw it in because it's not an easy one. But we can quickly put that together by doing the following. First, we're going to find the midpoint. Then we're going to find our slope.